All right, so now that we know how to calculate the limiting reactant, we can move into figuring out how much of our excess reactant remains when the reaction finishes. So thinking back on what those definitions were, the limiting reactant is basically going to say that the reaction can continue to go until I run out. When the limiting reactant runs out, the reaction stops, right? Think back to your s'mores example. When you run out of graham crackers, you stop making s'mores because you can't anymore. So you're still going to have marshmallows there, but no more s'mores. When we did our last problem, we solved for our limiting reactant. We found out a couple of things. We found out that 30 grams of zinc produces 37.34 grams of zinc oxide. And we found out that 30 grams of O2 produces 152.58 grams of ZNO. So basically, big picture, what we're looking at here is that our zinc, right, is our limiting reactant, and our oxygen is our excess reactant. Now, what we need to do from here is figure out if we use all of our zinc, how much oxygen do we need? So we're going to start again with our 30 grams of zinc. Okay, with that 30 grams of zinc, we want to go from zinc into oxygen. We want to know if we react 30 grams using the ratios that exist in this equation and the molar masses of the compounds that we have. If we react 30 grams of zinc, exactly how much oxygen do we need to produce our product? So with 30 grams of zinc, first thing we want to do is convert that into moles, right? And we remember that the molar mass is 65.38 grams for every 1 mole. Grams of zinc and grams of zinc cancel out. If we're in moles, we can go from moles of one thing to moles of another. That's our mole ratio. For every 2 moles of zinc, you get 1 mole of O2. Again, these numbers come straight from the equation, those coefficients. Now that I'm in moles of oxygen, I can go into grams of oxygen. For every 1 mole of O2, it has a molar mass of 32 grams. If I do some math here, we end up getting an answer of 7.34 grams. This 7.34 grams, if we cancel out all of our units here, right, is the amount of oxygen used when we react 30 grams of zinc. So this number is specific, right? Number 2, our question is, what is the excess reactant? We identified that above, right? It was oxygen. How much of the excess reactant remains is the question we now have to answer. The equation to solve for this is what we have, all right, minus what we used to give us what's left over. So what we have is up here, 30 grams of O2 minus what we used, .34 grams of O2 equals what's left over, 22.66 grams of O2 left over. So basically, what this is getting at, putting it all back in relationship to that s'mores problem we've been talking about, is that if you have 100 marshmallows and you have 10 graham crackers, okay, in our equation that we used, remember we used 2 marshmallows per s'more. So if we have 100 marshmallows and 10 graham crackers, if we use all 10 graham crackers to make s'mores, we need to have 20 marshmallows. So basically what we've done is use this stoichiometry to find the 7.34 grams. That's like finding how many marshmallows do we need or do we use to create 10 s'mores. Okay, well we use 20 marshmallows to create 10 s'mores. Then down here for number 3, you took what you started with or what you have minus what you used. So we had 100 marshmallows. We calculated that we would use 20 of them to make 10 s'mores. What's left would be 80 marshmallows. So that just takes everything you've just done and puts it back in relationship to that keeping it simple s'mores example that we used. So basically the point of our limiting and our excess reactant is to be able to look at an equation or a chemical formula and decide if I'm going to have this much of one substance, how much of another substance do I need? Or if I have this much of one substance, how much can I produce? Right? It allows us to not be wasteful in the lab, especially since some of our reactants or the chemicals that we use are really expensive. Right? So it reduces our waste. It also just makes things pretty simplistic in the fact that we know exactly what we're looking for, how much of things that we need, right? And whether our yield or that number that we get at the end is accurate or not. Okay, so you did all on Tuesday, right? You spent time with stoichiometry. This limiting and excess reactant is just taking stoichiometry and giving you a reason for doing it, right? Giving you a relationship or a problem in which you can see the actual benefit of it.